Okay. All right. I'll just do the evens in order. We'll just see where we go here on this. Um, all right, so a couple ways to solve this. There's the analogous like algebra problem, which is u squared equals 1 or x squared equals 1. You're supposed to remember that there's two solutions to this. It's plus or minus 1 on that. Now, the other option is to subtract 1 from both sides and then do a difference of squares, sine x minus 1, sine x plus 1 equals 0. So sine x either equals 1 or sine x equals -1. And so this is where you really got to know your unit circle. Sine is the y value. So where is the y value? 1. Well, that's at pi over 2. Where's the y value? -1. That's at 3 pi over 2. So you are going standard, 0 to 2 pi counterclockwise. Like you're going the standard direction on that. Any questions on that?
No, that one makes sense.
Okay. 38 here. What you do is you treat this as if it's a standard factoring problem. Like there's always an analogous, like just pure algebra problem. I like U for my substitution. And if you're more comfortable factoring like this, with the U's instead of the sine X, that's a good thing. So it's -2, sorry, that does not, sorry, I got the wrong coefficient there. There it is. Okay. So that does not work either. So I got them in the wrong place. 2 and 1. So what that means over here is that it's 3 sine x minus 2 sine x minus 1 equals 0. So when you solve each of these, it's sine x, 3 sine x minus 2 equals 0, sine x minus 1 equals 0. So we're trying to figure out where sine x equals 1 and sine x equals 2/3. So the sine x equals 1 is the easy one. That's where the y value is 1. That's at pi over 2. This one is more difficult. So there's actually two places it equals 2/3, but they're not like nice values. There's one there and one there. So the way to find it is to use inverse sine. And that'll give you the one in the first quadrant, but it won't give you the one in the second. To get the one in the second, it's pi minus sine inverse of 2/3. And if that doesn't make any sense, this is not a great problem. Usually they come up with nicer ones than this.
Hmm.
So I do apologize if that's really unclear.
I
But the
think it
idea
makes
is like,
sense.
let's just say X is like 67 degrees, and it would be 180 minus 67 degrees for the other one.
Okay.
Is that okay?
Yeah.
All right. All right, so number 40 here, secant squared 2x equals 2. So this one's more difficult. You're undoing secant with square root. So it's plus or minus the square root of 2. And secant is really cosine, 1 over cosine 2x, which means you can actually flip both sides. So it ends up reciprocal on both sides is cosine 2x equals 1 over square root of 2 plus or minus. And then if you rationalize the top and the bottom here, it's really cosine 2x equals plus or minus root 2 over 2. And that's a little bit nicer because those are nice places. That's on the 45, the other 45, the other 45, the other 45. Does that make sense? Is that reasonable where those would be? We'll do it in
Yeah.
degrees. Oh no, it says radian. We can't do that. Okay, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And the reason it's all of those is because it's plus or minus. Okay. Now, you got to deal with this 2x. So it's where 2x equals pi over 4. And it's where 2x equals 3 pi over 4. And it's where 2x equals 5 pi over 4. And it's where 2x equals 7 pi over 4. So for all of these, you're dividing by 2 or multiplying by 1/2, right? Times 1/2,
Hmm.
times 1/2, times 1/2, and so on. So it ends up being pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. And you probably noticed that the values all just got smaller, okay? And so the thing that you're supposed to account for here is 0 to 2 pi. It said that somewhere. So we've only gone like halfway around the circle. And you can kind of see the pattern here. It's incrementing by pi over 4 each time.
Yeah.
So that means you got to keep going. So, one, you can see the pattern, 1, 3, 5, 7. There's also 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. And you might wonder, well, where do you stop? Well, you stop when you're outside of this interval. This is just right up next to it.
Okay. So you just do any value that could work.
Well, that's the whole point. That there's like so many variations on these problems here. The other thing that we could have done is the double angle formulas. Um, this is probably the best way. This whole thing with the interval though is more complicated than I just made it. I sort of just went through it pretty quickly. Um, so I don't know. I know it's not a great answer, but let's go to 46. 42, 43, and 44 are sort of more calculator problems. This is more of a by hand problem. So you get everything on one side. So you subtract tangent theta, you subtract 1, and then you're basically like factoring. It's like 2x squared minus x minus 1. So you got to remember how to factor 2 tangent theta. This is minus 1 plus 1 like that. And so you set both of these equal to 0. Tangent of theta plus 1 equals 0. Tangent of theta minus 1 equals 0. So you've got tangent of theta equals negative 1/2. Tangent of theta equals 1. And so these are not on the unit circle, right? So you have to like remember what tangent is. Now you might remember that tangent is the ratio of sine and cosine. So on the 45-degree here, they are the same. So this is 45 degrees and 225 degrees for that one. The negative 1/2 is a little bit more difficult. You're looking for a place on the unit circle where the ratio of sine over cosine is negative 1/2, which does exist. No, it does not exist. What am I thinking? I don't believe there is a place where that works. So there's only certain ratios you can get. Like, let me just check here. Tan. Why did it do that? Okay, a tangent minus 1/2. Um, yeah, so this one doesn't have like a known value, so you have to use the calculator on that one.
Okay.
So like the ones that you do know are like, what is square root of 3 over 2 over 1/2? Or what is 1/2 over square root of 3 over 2? Like there's only a few that really work out perfectly. Something like that. Okay, 48 is kind of like that one we did. What number did we do? Kind of like this one we just did here was at 40. Um, the reason I say that is whenever inside the parentheses here is not just the x or the theta, you end up getting more work to do basically. So if you divide both sides by 2, you're now trying to figure out where does the sine equal to 1/2 on the unit circle. So that's the y value. That's there and that's there. It's at this is degrees, 30 degrees and 150 degrees. So 2 theta equals 30 degrees and 2 theta equals 150 degrees. Then you divide by 2. So you get theta equals 15, theta equals 75. And the problem, what you should notice is when it gets smaller like this, you're gonna realize, oh, I have to keep going. But this one's different than the last one. Like it's not that the next one is 270, like going up by 120. You have
Mm,
to go like all the way around again. So if you add 360 to this and then divide it by 2, add 360 to this one and divide by 2, you can see that it's 180 plus 15, 195, 180 plus 75, which is 255. Yeah. And you might wonder, well, when do I stop? Well, that's a tough question. It depends when you run out. Like you're actually supposed to keep incrementing the period by the period here. So there's like a bigger discussion that we're not having because they're not really introducing this in the right steps. But if you tried to add another 360 over 2 here, another 180, that's too big. But here, if you add another 180, it is also too big. So that's the idea generally.
okay.
All right. So I kind of got, I guess I'm gonna just stop here unless if you're okay with that.
Yeah, that's fine.
I'm gonna get through everything. So we'll just, do you need a lesson on Sunday by chance? That would be a good day if you wanted us to kind of reschedule for, if that's available for you, or Tuesday of next week.